Welcome to Brain Vision.
In this problem, we're asked to verify that some equations are dimensionally correct. So we'll just go through them one by one, and we'll plug in SI units. You could do it using dimensional analysis instead of SI units, just a generic dimension. But SI units are what most people are familiar with. So we have the first example. First problem is H equals 2s cos theta over rho r g. So looking at these units, we have the only one you might not know is S. S is surface tension. So the 2 has no units, so we don't have to worry about this. S is going to have units of newtons per meter. And then cosine theta doesn't have any units either. That's unitless. So then rho, that's density, so that's going to be kilograms per meter cubed. And R is meters. And G is meters per second squared. And now we just have to simplify this. So what we have here is a newtons per meter over, this is kilogram. Meters times meters is meters squared over, this is meter cubed second squareds. Meter cubed second squareds. So let's put our brackets in there, and let's see what we've got here. And if there's a lot of ways we could go about this, but let's be sort of clever with it. And if we realize that we've got this newtons here, we could expand this into kilogram meters per second squared, or we could realize, oh, we've got this kilogram, there's a meters here, is a second squared. So we could look at that and go, okay, well, let's just keep this in newtons per meter, and then realize that this here, we've got a newton kilogram meter per second squared. So this is meters squared, so there's an extra meter there. And then there's this meters cubed down here. All right. And so what do we got here? Well, we've got a meter over meters cubed. So that's we can cancel that and make this just a meters squared. And now what's this? Well, this is newtons per meter over newtons per meter squared. So newtons cancel, and we've got meters over meters squared. So this is just going to simplify to meters. And h is height, and height is indeed measured in meters. So this checks out. H is indeed measured in meters. So that is a check for being correct. So moving on to the next example, and we'll do it in a different color. We have B has this nu equals root capital P over rho. And we've got to be careful. It could look like that this little symbol is supposed to be V for velocity, but this is nu, the Greek letter nu for frequency. At least that's what I think it is. If you look in the example problems, it looks like it. At least that's what this symbol is supposed to be. So here we go into dimensional analysis. So square root, and the dimensions of pressure are newtons per meter squared. I'll put those in some brackets. And then over square root of, we got kilograms per meter cubed. So what do we got here? Well, we've got this meters squared, this meters cubed. So if we're careful with our dimensional analysis here, we can just cancel that meter squared, and we're just left with this meters here. So this is square root Newton, and we've got this meters over kilogram. So here's an example where it's better to expand newtons. So square root, what we got here, newtons, if we remember, that is a kilogram meter per second squared. And I'll expand that over here. And we've got a meter, and then there's this remaining kilograms. So this kilograms cancels, and what are we left with? Square root of meters squared per second squared. And if we square root that, what we have here is nu is units of meters per second. Well, if we were talking about velocity, that'd be correct. But this is nu. Nu is for frequency. This is supposed to be a frequency here. Frequency, which does not have units of meters per second. The correct units of frequency are hertz, or inverse seconds. We got this extra unit of meters here. We actually have a linear velocity. So this does not check out, right? So this is not dimensionally correct. Moving on to part C, we have our third equation, which is V for volume equals pi p r to the fourth t over 8. And then this sort of curly n thing is actually eta L. So we're looking for units of meters cubed here. So pi doesn't have any units. P is pressure, which we, in the last example, in a previous example, we did pressure as newtons per meter squared. But here, I think it's easier if we just say it is, we keep it its unit of pressure, which is pascals. R is a length, so that's meters to the fourth. And then T is time, seconds, over 8, it's unitless. So eta is the coefficient of viscosity, which has these units of Pascal seconds, if you look it up. Some people say newtons per meter squared seconds, but because we have this Pascal and this Pascal, it's easier to just leave it like that. And L is another length. So meters. So pascals cancel, seconds cancel, and meters to the fourth over meters is going to leave meters cubed. So what we're going to be left with here is V has units of meters cubed, and volume does indeed have units of meters cubed. So this is correct. And finally, moving on to our fourth example, D, we have again nu equals 1 over 2 pi square root of mgl over I. So these, again, 1 over 2 pi, no units there. So we got square root. M is units of kilograms. And G, that is meters per second squared. And L is meters. And I'm just going to extend this sort of radical symbol down so we can put it all under 1 here. And then I, this is something called the moment of inertia, which has units of kilogram meter squareds. So we can see here kilograms cancel. And this is meters times meters. That's meters squared over meters squared. So these are going to cancel, which just leaves us square root of 1 over second squareds. Or when we square root 1 over second squareds, we're just going to end up with 1 over seconds. So this is, once again, remember this was frequency. This little curly v was frequency, which is measured in units of hertz or inverse seconds. 1 over seconds. So this also checks out. So it looks like A, C, and D are correct, and B is incorrect.